Class 11th Chemistry, Unit 4 Chemical Bonding and Molecular Structure, and in this video we will discuss about hybridization of elements involving d orbitals and formation of PCl5 and SF6. Now this table represents the different type of hybridization in which d orbital are participating. If hybridization is dsp2, that is 1d, 1s and 2p orbital undergo hybridization, then we will get the 4 dsp2 hybrid orbitals, and these 4 dsp2 hybrid orbitals arranged in a square planar way, and shape of that molecule in which central atom undergoes a dsp2 hybridization will be square planar. Examples are NiCN4 2- and PTCl4 2-. Hybridization is sp3d. It means 1s and 3p orbital along with 1d orbital participating in hybridization. Then we will get the 5 sp3d hybrid orbitals, and these 5 sp3d hybrid orbitals arranged in trigonal bipyramidal way. Okay. Examples are PF5, PCl5. About this PCl5 we will discuss in detail. Hybridization is sp3d2, that is 1s, 3p orbitals and 2d orbitals of outermost shell intermix and form 6 sp3d2 hybrid orbital, and out of these 6 sp3d2 hybrid orbitals, if 5 orbitals make a bond and one orbital contain one lone pair of electron, then geometry will be square pyramidal. Okay, an example is BRF5. Now you can see in this case these 6 sp3d2 hybrid orbitals are present in octahedral manner. Okay, but one of these hybrid orbital contain this one lone pair of electron, and remaining hybrid orbital overlap with the p orbital of F and form this type of geometry. This is called square pyramidal geometry. Okay. Now if hybridization is sp3d2 or d2sp3, again these we can say 6 hybrid orbitals are arranged in octahedral manner. Now what are the difference between these two? In sp3d2, the d orbitals of outermost shell take part in hybridization, while in case of d2sp3, the d orbitals of n-1d shell take part in the hybridization. Examples of sp3d2 hybridization are SF6, CRF6 3-, an example of d2sp3 is CONS3 3+. Okay, the formation of SF6 we will discuss in detail. First come to formation of PCl5, that is phosphorus undergo sp3d hybridization. In the ground state, the outermost electronic configuration of phosphorus is 3s2 3p3. Okay, in ground state only 3 half-filled orbitals are there, but phosphorus is forming 5 bonds. That's why one electron from the 3s orbital excited to one of the 3d orbital. Now we will get these 5 half-filled orbitals. These 5 half-filled orbitals undergo intermixing and generate 5 sp3d hybrid orbitals, which are directed towards the 5 corners of a trigonal bipyramidal. Okay. Now these 5 sp3d hybrid orbital overlap with half-filled orbital of chlorine to make 5 bonds. Okay. Now these in we can say in red color, these are the sp3d hybrid orbital with phosphorus, and these 5 chlorine atoms, each chlorine atom overlapping with its half-filled p orbital with sp3d hybrid orbital of phosphorus and forming 5 bonds, and these 5 bonds are arranged in this way. in trigonal bipyramidal manner. Okay. Now, this structure you can also represent trigonal bipyramidal geometry of PCl5. Okay, you can see this is phosphorus, and in one plane, three hybrid orbitals are there, forming the three PCl bond, and one is above the plane, and one is above the plane, and one is below the plane. Okay. Now, all the bond angles in trigonal bipyramidal geometry are not equivalent. Out of these five bonds, three PCl bonds lie in one plane and make an angle of 120 degree with each other. These bonds are termed as equatorial bonds. You can say this, that is in one plane. Again, see, this is phosphorus, and these three phosphorus chlorine bonds are in one plane at 120 degree. This is 120 degree, this is 120 degree, and this is also 120 degree. And the remaining two phosphorus chlorine bonds, one lying above and the other lying below the equatorial plane, make an angle of 90 degree with the plane. These bonds are called axial bonds. Now you can see this is one above the plane and one below the plane, and this angle is 90 degree. Okay, now we can see two type of bonds are there. In a plane, three bonds are there, and these bonds are equatorial bonds, and the bond above the plane and below the plane, these are known as axial bonds. Okay, as the axial bond pairs suffer more repulsive interaction from the equatorial bond pairs, therefore axial bonds are slightly longer and hence slightly weaker than the equatorial bonds, which makes PCl5 molecule more reactive. Okay, that's why we can say in PCl5 bond all the five PCl bond lengths are not equal. Axial bond lengths are slightly longer. Axial bond lengths are slightly longer compared to the equatorial bond lengths. Clear? Now come to formation of SF6. In SF6, sulfur undergoes sp3d2 hybridization. How? In ground state, electronic configuration, outermost electronic configuration of sulfur is 3s2 3p4. But again, there the two half-filled orbitals are there. But forming the in case of SF6, sulfur is forming 6 bonds. That's why one electron from 3s and one electron from this 3p, which are paired, jump to the empty 3d orbitals. Okay, now you can see there is 6 half-filled orbitals are there. These 6 half-filled orbitals mix to each other and generate 6 sp3d2 hybrid orbitals, and these orbitals are projected towards the 6 corners of a regular octahedron in SF6. You can say this is the geometry of SF6 octahedral. You can also see these 6 sp3d2 hybrid orbitals overlap with singly occupied orbitals of fluorine atoms to form 6 SiF sigma bonds. You can see from this diagram, this is the sulfur, okay, having 6 sp3d2 hybrid orbital, and each sp3d2 hybrid orbital overlap with the half-filled p orbital of fluorine, making 6 SF sigma bonds, and thus SF6 molecule has a regular octahedral geometry. This one, regular octahedral geometry. You can also make this. Now in octahedral geometry, actually 4 bonds are in one plane, making square planar, and one bond is above the plane and one bond is below the plane. If you join the corners of these, then we will get the one octahedra. Okay, if you will not join, then this geometry is sufficient for SF6. Okay, thank you.